Okay, welcome back. We are going to start working on an equal intersecting roof, and we'll take this in a couple phases here. First off, I've already calculated my slope ratio common, which of course is the hypotenuse of a 160 rise 250 unit run. Hypotenuse, of course, divided by the common unit of run. Slope ratio common, 1.1873. The slope ratio hip up top here is, of course, the hypotenuse of the unit rise of 160, the unit run hip of 353.6. That hypotenuse divided by the common unit of run 250 gives me a slope ratio hip of 1.5525. If you have any questions about slope ratio and then difference in jacks, just go back to the slope ratio video. Okay, first we're going to go ahead and calculate the line length of our major common. All these will be line lengths down the left-hand side here, just in case you're all wondering. So these are all line length measurements that we're going to calculate. So first off, we will start with the line length of the major common. So the major common, of course, is half the span of the major roof, which is from there to there. So half the span of 90/150 is 45/75. So the run of common is 45/75. We multiply that by our slope ratio common, 45/75, multiplied by 1.1873, gives us a line length of our major common of 5431.9. Now, if I should be using a different calculator, you should be storing your slope ratio common in storage location A. You should be storing your slope ratio hip in storage location B. And then, of course, your difference in jacks is the slope ratio common multiplied by your spacing 400 on center gives you the line length of that particular triangle, which is what we subtract off of the line length of a common rafter to start calculating the line lengths of our jacks. So this is how much a jack shortens for every spacing of 400 traveling down the hip. So of course let's go ahead and draw one on here. Our first major jack would be there. That jack is shortened by a spacing of 400. So we multiply that spacing times the slope ratio common. That is the difference in jacks. So we subtract 621 off of the line length of the major common, and that will give us our first jack. Okay, moving along. The line length of our minor common, of course, we have to find half of the span of our minor roof will be the run of our minor common, which is right here. So if we just simply take 9.6 meters to here, from the end of the building to here, then we have to just simply subtract off of that the 6,700, and what it leaves us with is a run of 2,900 for the run of our minor common. We multiply that by slope ratio common. So 2,900 times 1.1873, or recall A, equals, we have a line length of our minor common of 3443.2, rounding to the first decimal place. Okay, so now we go back to our major hip. We simply take the run of our common, which is 45/75, and we just simply multiply that by slope ratio hip, 1.5525. We now have a line length of our hip of 7102.7. Of course, what I'm going through here is exactly the same sheet as the resource that you can download just underneath this video. Now we'll go back to the minor hip, the line length of our minor hip. We simply take the run of our minor common, and which is 2,900, and we'll multiply that by slope ratio hip times 1.5525 gives us a run, or sorry, a line length for our minor common hip of 4502.8. 3. Now, one thing to keep in mind, so that will give us the run of our hip here, from there to there. That's the line length of our hip. Now the line length of the hip here, we also have, of course, that's the same as this side. We'll go ahead and we'll do this in red. So we have our minor hip. That will be the exact same length as our supported valley. And now if we go to our major hip, the line length of our major hip will be exactly the same as the line length of our supporting valley. So that goes ahead and answers those two. All right, I'm going to clean up this page and we will continue with the next portion of this. Okay, now we're going to calculate our first major hip jack and our second minor hip jack. So this is, of course, really easy. Once we actually have calculated the line length of our major and the line length of our minor, all we simply have to do is subtract for our first major hip jack. All we have to do is erase some stuff here. So 45.75 is the run of minor, multiplied by 1.1873. So we have the line length of our major rafter of 5431.9. We now just simply, it's the first major hip jack. So we're moving over simply one spacing from there to there. So that one spacing is simply one difference in jacks. So we just subtract from this, minus, and what I do is I put things in brackets for difference of jacks. So I'll do the, let's go 5431.2 minus, because sometimes, like for our minor, second minor hip jack, we'll sometimes subtract more than one difference in jacks if we want our first, second, or third hip jack. In this case, the major, it's only one jack, so we'll minus, and in brackets put 1 times difference of jacks, which is 621. So we'll simply go, I'll do it on my calculator, we'll subtract from that in brackets. In brackets, 1 times, and what's my difference in jacks? 621, close bracket, enter. So we should have now a first major hip jack line length of 4810.9. Now we will simply go back to our minor roof, and we have 2900 times our slope ratio common, which is 1.1873. So the line length of our minor common is, we'll do this in a different color, 3443.2. We'll subtract from that. Now it's asking on this sheet, it's asking for our second minor hip jack. So from our minor common, we have our first, and here's our second minor hip jack, from there to there. So we know we have two spacings, we have two difference in jacks. So we'll go 3443.2 minus, in brackets, 2 times 621. So I'll do that on my calculator, minus, open bracket, 2 times 621, close bracket, which gives us a line length of our second minor hip jack of 2201.2. Okay, we'll get set up for a couple more. Okay, now we are going to cover our first, second valley jack. So this will be the same whether we're working on the major roof or the minor roof. And the way this works is this point right here on our major roof, this would be our layout point. And then our new point here that we've talked about in class, right there, I'll make that yellow, that is our change point. Okay? So that is where the spacing is now intersected by our supported valley coming in. So what we have to do first is we have to find out what this distance is from our layout point to our change point, so we can determine how many spaces that we have before we get to our change point. So I've already worked this out to 1685. We take the length of our building, 18,760. We then subtract off this amount here, which takes us all the way to our minor ridge. We then subtract off the run of our minor, which gets us right to our change point. Then from that, we subtract off half the span, which is the run of our major, which is 45.75, which takes away from here to here. And then, of course, what we're left with is our layout point to change point measurement. Okay, so 1685. Now down below, I have a little formula that we use to calculate. So the first one we're doing here, it's asking for the second major valley jack. Okay, so let's go ahead and draw a couple of valley jacks on. So let's say this is the first one, and that's the second one, our second major valley jack. So first we have to determine how many spacings we have. So we take our 1685, which is our layout point to change point. We'll go ahead and just write the numbers down here. So 16, let's go red. 1685. We divide that by our on-center spacing. Okay, so let's divide that by on-center spacing of 400. So divide that by 400. Now that gives us, by my calculator, 4.2125. That gives us spaces. So that's how many spaces that we have. So we have 4 full spaces, or we can call them 4 full rafters. So we'll draw them on here. I'll do my best. 1, 2, 3. What's wrong with my pen? I don't know what's wrong with my pen. 3, 4. So let's say that's 4, and our fifth one's over here. This is not to scale, obviously. So we know that after 4 full spaces, 1, 2, 3, 4, the space left right in here is a 0.2125 of a space, which means that the remainder of the space is on the other side of the change point. So what we want to do is find out how much of a space that is, because we know one full space, we can take one full space, which is 400, and multiply that up here by our difference in jacks, and then that will give us the reduction in line length from our major common. So what we do here, this works really well. We're going all of the way to, let's go red, we're going all the way to our second valley jack. So from the change point right here, we're traveling over this far. You can almost make a little right triangle there. We're traveling over that far. So how far is that distance? Because we can simply take that distance, which is comparable to the run of the reduced run from our major common rafter, and we can simply multiply that amount by our difference in jacks. So we subtract, we take this, we have 4.2125 spaces or rafters to our change point. We now subtract the rafter we're after. Well, which rafter is that? Well, we have 1, 2, 3, 4, 5, 6. So the second major valley jack rafter is rafter number 6. So on my calculator, I'll go -6, which is the rafter we're after. Well, now that gives us, I'll go ahead and erase this. Now that gives us -1.7875. We have 1.7875 spaces. That's spaces. That's how many spaces we have after the change point. So that is our distance that we can now, 1.7878 spaces, we can multiply that by our difference in jacks, and then that will give us the reduced line length of our common rafter. Now we have to keep in mind that this is a negative number and this plays into our favor. So we subtracted the rafter we're after, which is number 6. I'll write that down here. Now we multiply that by our difference in jacks, which is 621. So I'll go ahead and multiply that by 621, which gives us negative, I'll write that below it, it gives us a negative 1110, pretty much even. So now we still have a negative number. This is the amount of shortening we're going to have on the major common line length. So since it's a negative number, we're simply going to add this to the line length of our common rafter. That line length is 5431.9. So we'll simply take, we have that negative 111 minus. So we have that negative 1110. We'll now just simply add to that, which really subtracts that number. We'll add to that the line length of our common rafter of 5431.9, and that now will give us the line length of, in this case we have line length of our second major valley jack, and that equals 4321.9. And that is the line length of this rafter right here, second major valley jack. Okay, now we're going to go ahead and calculate our first valley cripplejack rafter. So our first valley cripplejack rafter will be falling somewhere around right there. It falls on the supporting and the supported valley. So how do we determine what rafter that is and how far over is it? The distance that we're really looking for here is the distance from that rafter to the minor ridge. That's the distance we're looking for. So I'm going to zoom in on this. Well, actually, I've already calculated out a couple dimensions that we have here. So we need this distance here from the layout point to the supporting valley, and then we need the distance from the layout point to the minor ridge. So we first take the distance. I've already got both of those. So 2900 is the distance from the layout point to the supporting valley. And then on the bottom, the distance from the layout point to the minor ridge is 4585. Okay. So the way that we determine how far over this rafter is, the way that we determine how far over that is, I'm going to go ahead and blow this up a little bit, is we have to take the distance to the supporting valley and divide that by our on-center spacing. So we'll take the 2900, I'll get my calculator handy. So we're going to take the 2900 and we're going to divide that by our on-center spacing of 400. Oh, sorry about that. Of 400. And what does that give us? So 2900 divided by 400 gives us 7.25. So we know that from our layout point to what this ends up being is another change point, our supporting valley is 7.25 spaces. So if it's 7.25 spaces, now I'll go ahead and shrink this down a little. We know that we have 7 spaces, 1, 2, 3, 4, 5, 6, call it 7. And from the 7th space or the 7th rafter, it's a 0.25 to the change point there. So if it's 7 full rafters, we know that the rafter number 8 will be the first rafter landing on the supporting valley, which makes it our first valley cripplejack. So if it's the 8th rafter, well, what's 8 times our spacing? 8 times 400 is 3200. So we know that this distance is 3200. Great, that's 3200. Now we know that this distance here is 4585, the distance from the layout point to the minor ridge. So let's type in, we want to go 4585. We'll subtract from that the 3200, right? Subtract from that 3200. And what we're left with is the distance from that valley cripplejack to the minor ridge. And that distance is 1385. So that's 1385. Well, it's just this easy. That distance is the same as this distance right here. And it's also the same as this distance here. So we simply take the 1385, we times it by 2, and then we multiply the answer. Let's go ahead and times it by 2. That gives us 2770. Then we simply multiply that by our slope ratio common, which is 1.1873. So we'll times that by slope ratio common. So I'll multiply that by 1.1873, and that gives us a line length of 3288.8.8. That is the line length of our first valley cripplejack. All right, well, that was kind of fun. If you have any questions, feel free to drop me a note, and I'll do my best to answer them as soon as I can. Take care and have a great day.